Some people remember a children's book spelled one way. Others remember it another. A logo appears incomplete to some, missing something they're certain was always there. A line from a movie feels wrong, even when played back exactly as recorded. And in each case, it's not one person, it's thousands, sometimes millions, all remembering the same thing that never existed. The Mandela Effect refers to a documented pattern where large groups of people share identical memories that conflict with verifiable records. The term was introduced in 2009 after many people reported remembering Nelson Mandela dying in prison in the 1980s, despite his confirmed release in 1990 and death in 2013. Since then, similar cases have been catalogued across widely recognized cultural references. The children's book series is officially Berenstein Bears, not Berenstein. The Fruit of the Loom logo has never included a cornucopia. The Monopoly character has never worn a monocle. And the line in Snow White is magic mirror on the wall, not mirror mirror. These discrepancies are not isolated. They follow a pattern, specific, repeatable, and widely shared. Not vague impressions, but consistent details recalled with confidence. Memory research provides a framework for understanding this. Human memory is reconstructive, not archival. Each recall is a reconstruction, shaped by expectation, familiarity, and prior knowledge. The brain fills gaps, it resolves uncertainty, it prefers what feels correct over what is exact. And when those reconstructions are repeated, shared, discussed, reinforced, they stabilize. They become familiar. They become certain, across individuals, across time, across the same details. What happens next depends on how you interpret what you're about to hear.
The most grounded explanation is that memory isn't a recording. It's reconstructive, rebuilt each time from fragments, patterns, and expectations. That means what we recall is shaped as much by what should be there as what actually was.
Yes, that's well established in memory research. Memory is assembled, not replayed, and it's vulnerable at encoding, storage, and retrieval. Errors are not rare. They're a normal feature of how the system works.
And that reconstruction relies heavily on schemas. The brain uses familiar patterns to fill in missing details automatically. This makes memory efficient, but it also makes it systematically biased,
which explains why the errors are consistent rather than random. Berenstein fits a common linguistic pattern better than Berenstein. The brain resolves ambiguity into something more familiar.
The same applies visually. A monocle fits the Monopoly man's aesthetic, so people remember it, even though it was never there. The mind completes the image in a way that feels correct.
This is pattern completion. The brain prioritizes coherence and fluency over exact recall. If something feels right, it's often accepted as true.
And once a false version appears, social reinforcement strengthens it. Repetition increases confidence, even when accuracy decreases. This is a well-documented effect in group memory.
That's memory conformity. People align their recollections with others, especially when their own memory is uncertain. Over time, the shared version becomes dominant.
Online environments accelerate this process. A repeated claim becomes familiar, and familiarity is often mistaken for truth. People may adopt a memory they didn't originally have.
And confidence grows with repetition, not verification. The more often something is heard, the more real it feels. That creates strong but inaccurate consensus.
So the Mandela Effect isn't just forgetting. It's structured misremembering shaped by shared inputs. The system is working as designed, not malfunctioning.
Exactly. The errors follow direction. They move toward familiarity and narrative logic. They're not random distortions.
Mirror, mirror sounds more natural than magic mirror. The brain prefers the version that fits cultural rhythm and expectation. That preference reshapes recall.
The same applies across many examples. The brain resolves uncertainty into the most stable and recognizable form. This creates consistency across individuals.
Which means these aren't glitches. They're outputs of a system optimized for meaning rather than precision. That's why so many people end up with the same wrong version.
When people share the same cultural inputs, they tend to produce similar reconstructions. The environment shapes the memory as much as the event itself. That leads to convergence.
A kind of collective reconstruction. Not coordinated, but aligned through shared exposure and cognitive shortcuts. It's an emergent pattern.
And most cases fit this model cleanly. Cultural artifacts like logos and phrases are especially vulnerable. They're stored impressionistically, not exactly.
Which makes them easy to reshape over time. Small distortions accumulate and stabilize. The result is a shared but incorrect memory.
And importantly, this doesn't require any change in external reality. The explanation stays entirely within known cognitive processes. It's sufficient, at least at a basic level.
So, from a cognitive standpoint, the Mandela Effect is expected. It reflects how memory operates at scale under shared conditions. Nothing unusual is required to produce it.
The psychological model accounts for the majority of cases. It explains direction, spread, and confidence. That makes it the strongest baseline explanation.
And it does so without introducing unnecessary assumptions. The simplest explanation remains internal, not external. That keeps the model grounded.
However, the consistency of these errors still stands out. The alignment across individuals is unusually tight. That's where the explanation starts to feel less complete.
Because even if the mechanism is understood, it's not clear why it produces the same answer so reliably.
So the cognitive model explains direction and mechanism, but it starts to strain when we look at convergence. If memory is reconstructive, we should expect variation in the errors. Instead, we often see the same specific incorrect detail repeated across many people.
That's the core tension. Schema completion explains why an error feels right, but not why one exact version dominates. You'd expect a range of plausible alternatives, not a single consistent outcome.
Right. The distribution should be wider. Different people should resolve ambiguity in slightly different ways. But in these cases, the resolution seems unusually uniform.
Which suggests there may be strong attractors in the system. Certain incorrect versions are more cognitively stable than others, but the strength of that stability is not fully explained.
It's not just that people are wrong, it's that they're wrong in the same way. That narrows the space of possible explanations. It starts to feel less like noise and more like alignment.
Social reinforcement explains how an error spreads after it appears, but it doesn't fully explain where the initial aligned error comes from. There's still a gap at the origin point.
Exactly. Contagion requires a source. For many of these cases, that source isn't clearly identifiable. We see the outcome, but not the first instance.
And in some reports, the memory predates widespread discussion. That's difficult to verify cleanly now, but it complicates the model. It suggests the alignment may not be purely social.
Even if shared media plays a role, it would need to be remarkably consistent across individuals. The same distortion would have to propagate early and widely. That's possible, but not always demonstrable.
So we're left with a system that explains spread well, but origin less clearly. The first occurrence of the shared error remains hard to pin down.
There's also the issue of specificity. These aren't vague distortions. They're precise insertions or substitutions. A cornucopia, a monocle, a specific spelling.
That level of detail is notable. It's one thing to misremember broadly, another to converge on the same added element, especially when the element isn't universally obvious.
The cornucopia example is interesting because it's not a high-frequency object in everyday cognition, yet it appears consistently in reports. That raises questions about how that specific image becomes dominant.
Schema theory can account for plausibility, but not necessarily selection. Why that object and not another plausible addition? The choice itself needs explanation.
It suggests the system isn't just filling gaps. It's selecting from a narrow set of preferred outputs. And we don't fully know how that selection is determined.
Another point is the strength of subjective certainty. People often report these memories with high confidence and contextual detail. That's consistent with false memory research, but still important.
Yes, confidence doesn't track accuracy, but the consistency of that confidence across individuals is worth noting. It reinforces the perception that something unusual is happening.
Especially because these are low-stakes memories. They're not tied to trauma or strong emotion, which are typical drivers of distortion. Yet, the certainty remains high.
That suggests the mechanism isn't purely emotional. It may be tied more to familiarity and repetition. But again, that doesn't fully explain the uniformity.
It's the combination: high confidence, low stakes, and high agreement. That combination is what makes the phenomenon stand out.
Then there's the idea of residue, secondary references that match the incorrect memory. These can include parodies, articles, or informal uses. They appear to reinforce the same error.
Those can be explained as independent instances of the same mistake. But the volume can make it feel like corroboration. It gives the false memory a kind of external support.
And once that support exists, it feeds back into the system. It strengthens confidence and encourages further spread. The distinction between origin and reinforcement becomes blurred.
Still, the underlying pattern remains. The same incorrect version appears repeatedly across contexts. That consistency continues to be the main point of tension.
So even staying within a grounded framework, there are edges that aren't fully resolved. The system works, but not with complete precision.
At this point, the issue isn't whether memory is reconstructive. That's established. The issue is whether the current model fully explains the level of convergence we're seeing. It accounts for direction and spread, but starts to feel incomplete at the level of precision.
Yes, it explains why people might be wrong, but not why they're wrong in the same exact way so often. The gap is small, but persistent, and it shows up repeatedly across different cases.
If the explanation were sufficient, we wouldn't keep returning to that same question. The uniformity of the errors suggests a stronger constraint than we've fully described. Something is tightening the outcome beyond basic schema effects.
One possibility is that cognition is more standardized than we assume. Given similar inputs, human minds may produce nearly identical outputs. That would make convergence less surprising, but also less understood.
That reframes the problem. It's not just about memory failing. It's about how similar different minds actually are, and whether that similarity is stronger than we're comfortable with.
There's also a shift in how the question is framed. It moves from, "Why is this wrong?" to, "Why is this the same wrong?" That's a different level of inquiry.
And it touches on something broader: how shared reality is constructed. If the reconstruction process is this aligned, then consensus may be more fragile than it appears.
Because agreement doesn't necessarily indicate accuracy, it may just reflect shared processing. That's a subtle but important distinction.
and it implies that much of what feels stable is continuously being rebuilt. Most of the time, that reconstruction stays close to reality, but not always.
When it doesn't, we notice. And when many people notice the same thing, it stops feeling like an individual error.
At that point, the anomaly isn't the mistake itself. It's the visibility of the system behind it. The Mandela Effect may be exposing how memory normally works.
Yes, not as a failure, but as a reveal. A moment where the reconstruction process becomes obvious. That's what gives it its unsettling quality.
Because it challenges the link between certainty and truth, a memory can feel stable, detailed, and shared, and still be incorrect. That's not intuitive.
And it raises a broader question. If this level of alignment can occur in trivial cases, could it occur elsewhere without being noticed?
That's where the discomfort comes from. Not that reality changed, but that our access to it might be less direct than we assume.
At this stage, the implications start to extend beyond memory itself. If shared errors can emerge this consistently, then consensus becomes a weaker signal of truth than we assume. Agreement may reflect shared processing rather than accurate recall.
Yes, and that has broader consequences. Many systems, legal, historical, social, depend on the assumption that collective memory converges toward accuracy. If convergence can stabilize around error, that assumption needs to be reconsidered.
It also highlights a metacognitive gap. People tend to trust vivid, detailed memories, especially when others confirm them, but this phenomenon shows that confidence and consensus can align independently of correctness.
Which suggests that reality, as experienced, is partially constructed through shared cognitive filters. Most of the time, those filters track well with external facts, but they are not guaranteed to.
And when they drift, the system doesn't immediately correct itself. It can reinforce the drift instead. That creates pockets where false versions feel stable and real.
There's also the role of modern information environments. Digital platforms can amplify alignment rapidly, reinforcing specific versions of events or details. That increases both the speed and scale of convergence.
But the phenomenon isn't entirely dependent on digital systems. Many of these memories trace back to pre-internet exposure. That suggests the underlying mechanism predates modern amplification.
So, what we may be seeing is an older cognitive process interacting with newer distribution systems. The internet doesn't create the effect, but it makes it more visible and persistent. It locks in certain versions.
And once a version is stabilized digitally, it becomes harder to disentangle origin from reinforcement. The system feeds back into itself. That complicates analysis.
It also means we may be overestimating how widespread any single example actually is. What we're seeing is a concentrated signal, not necessarily a universal one.
Another implication is that memory may be more collective than individual. If similar inputs produce similar outputs across people, then cognition operates within shared constraints. That reduces the independence of recall.
Yes, it suggests a kind of structural similarity across minds. Not identical, but close enough to generate the same distortions. That's a subtle but important point.
It reframes memory as partially distributed. Culture, language, and media shape not just what we know, but how we reconstruct it. The boundaries between individual and collective memory blur.
And that makes certain errors more likely to propagate. Once an incorrect version fits the shared structure, it becomes stable. It persists even when contradicted.
Which explains why correction can feel ineffective. The system resists change once a version is embedded. It's not just misinformation, it's reconstruction locking into place.
So the concern isn't that reality is changing. It's that our mechanisms for tracking it have limits. And those limits become visible in cases like this.
Yes, the anomaly is epistemic, not physical. It's about how we know, not what exists. That distinction matters.
But it still has consequences. If shared belief can diverge from documented fact, then verification becomes more important and more difficult, especially in low-stakes domains where precision isn't prioritized.
And those low-stakes domains may be where the system is most relaxed, which makes them more vulnerable to distortion. That's why these examples cluster where they do.
It's a quiet failure mode. Nothing breaks visibly, but something small slips. And once it does, it can stay that way.
At the end of this, the core explanation still holds. Memory is reconstructive, shaped by schemas, and reinforced socially. That accounts for most of what we observe without requiring anything beyond known cognitive processes.
Yes, and there's no strong evidence pointing outside that framework. The phenomenon is real, but the mechanism appears internal. The burden of proof remains on any alternative explanation.
At the same time, the remaining gaps are not trivial. The consistency, specificity, and confidence of these errors are not fully resolved. The model explains much, but not everything, with equal clarity.
Which suggests the issue may not be with the explanation itself, but with its level of detail. We understand the broad mechanisms, but not all of the constraints shaping their output. The system is mapped, but not fully parameterized.
And that leaves space for uncertainty. Not in the sense of unknown forces, but an incomplete understanding. There are still edges where the behavior isn't fully predictable.
So the Mandela Effect may not be an anomaly in reality. It may be an anomaly in our expectations of memory. We assume stability where there is reconstruction.
And we assume independence where there is shared structure. That combination creates the illusion of something external when the source is internal. It's a mismatch between intuition and mechanism.
But that mismatch matters. It shows how easily certainty can form without accuracy, and how collective agreement can reinforce that certainty.
Which raises a broader concern. If this can happen in trivial domains, it may occur in more significant ones without being noticed. The same mechanisms apply everywhere.
That's the part that lingers. Not the examples themselves, but what they imply about everything else.
Because most of the time, the system works well enough that we don't question it. Reconstruction stays close to reality, and errors go unnoticed. The illusion of accuracy holds.
But the Mandela Effect breaks that illusion, briefly. It exposes the process behind the memory. That exposure is what makes it feel unsettling.
Not because reality changed, but because our confidence in recalling it is less stable than we assumed. That's a subtle but important shift. It changes how we interpret certainty.
And it suggests that shared reality depends partly on shared reconstruction. Not just observation, but interpretation layered on top. That layer is usually invisible.
Until something small doesn't match. And once you see that mismatch, it's difficult to ignore.
The explanation holds. Memory reconstructs. It fills gaps, follows patterns, leans toward what feels right. That part is stable, but something in the pattern remains, tighter than expected. Not just error, but the same error. Not just distortion, but alignment. Thousands of people arriving at the same detail, the same spelling, the same object, the same missing piece, close enough to be explained, exact enough to feel incomplete. And it's always in the same direction, toward coherence, toward familiarity, toward something that fits better than reality itself. So the question shifts, not why memory fails, but how it agrees. Because if the system can produce identical reconstructions across independent minds, then what feels like personal memory may not be entirely personal at all. And if that's true, then the moment you recognize a memory as wrong, you're not just correcting it. You're stepping outside the version that felt most real.